basically, hi to the great builders in the space. I'm excited to discuss all that together. And I guess there's interesting points that we can share around this intersection of ZK and AI. Before we begin, I feel that overall the AI narrative has overtaken for past couple of months, and everybody's running around it with open eyes, and this is the kind of took the stage while actually a lot of improvements and innovation has been achieved for the past 2 years, especially in the ZK space. So now where we are is in this moment of realization that zero knowledge proofs for provable computation, whether it's AI or in general, could be a thing. Before we kick into the questions, I want all of you to share what you're working on, especially ZK AI aspects in your work and what keeps you up at night.
You want me to go first?
Yeah.
So, hi everyone. My name is Garvit, and I'm the founder and CEO at Electron. And we are in the business of reducing the cost of verifying ZK proofs and TE attestations on chain. We reduce this cost by more than 95%. And we do this by aggregating multiple ZK proofs and TE attestations together into a single proof. And that is then settled on the layer 1, and that allows you to share the cost of settlement amongst multiple projects.
Evan.
Hey, I'm Evan, co-founder of Mina protocol. We're working at the moment on kind of general purpose programmability for zero knowledge proofs, and both having an on-chain environment for that, for building ZK applications, as well as software for client side being able to program privacy applications and other things using zero knowledge proofs, all built on top of Mina's succinct blockchain. There are definitely some overlaps with AI, but I would say it's early days for a lot of the stuff we're looking at, particularly looking at verifying ML models and thinking about, can we get to a place where we can verify very large models, which is early days for, but we're starting to spend some time thinking about.
Scott Dykstra, co-founder and CTO of Space and Time. Space and Time invented a novel ZK circuit specifically for SQL to actually prove that database tables and the actual SQL execution against those tables, think filters, aggregations, sorts, joins, etc., are tamper-proof. And then we deployed that novel ZK circuit in a decentralized network called the Space and Time chain, so that we can index data from a large number of chains in a ZK-compatible way, and then allow smart contracts to run essentially ZK-proven SQL queries against chain state. And subsequently, AI agents can deploy contracts that kind of act as guardrails and policy engines that get data from Space and Time and ZK proofs from Space and Time. So we're excited.
Cheers. Harry Grieve, Gensyn, co-founder and CTO. We're a machine learning compute protocol. Concretely, we came to the kind of verification problem by wanting to develop ultra-high scale training systems. My co-founder and I come from kind of traditional machine learning backgrounds, and we both had the scaling challenges in the late 2010s, and we wanted to see how much compute we could crowdsource in order to essentially get a cheaper, higher scale solution to the problems that we had. This required a solution to verification, because if you don't trust the devices, you aren't necessarily going to be willing to use them. We approached the kind of a ZK problem actually more just in terms of polynomial interactive oracle proofs, so not without the zero knowledge component as a way to solve this. But we also have a variety of other verification systems, including our Verde partial replication verification system, which we released yesterday. So yeah, we think a lot about verification, and specifically with respect to very high scale compute.
In a way, we all agree that we're kind of in infancy of merging those two things together. But do you see ZK being the must-have type of function within the AI models, and what could be the value proposition for a consumer-centric or any type of AI models that ZK could fill in and add additional value?
Can I go first? So I just feel that if you're talking about any privacy or verifiability in AI, I think we cannot just talk about ZK. We have to talk about TEs as well. And I think TEs will be more important than just having ZK. The reason is because, especially if you talk about privacy applications, ZK does not have enough features in it to enable a privacy, like like a confidential training or something like that. You have to have more sophisticated encrypted computing features that are provided by something like, for example, Ts and FHEs. FHEs are not practical today, so we have to live with Ts. So you need to talk about these more additional cryptographic primitives if you're talking about these use cases.
Do you think that they're sufficiently secure? I think, over the last few years, the kind of Intel SGX debacles and all the issues of the side channel attacks, etc., made us ignore them, primarily because they were just widely regarded in the industry as not being sufficiently secure. I think the NVIDIA kind of CC confidential compute layer seems to be more secure, but do you have security concerns around it?
So this is a great point, and for personally, I feel that the whole Intel SGX issue was less related from the technicalities of the way these things work and more related to other issues. And this gave a bad name to the whole sector itself. So I think there's a relook that we need to do. And yes, I understand that there may be like supply chain attacks and all these things possible with these kind of technologies. But I think we have learned so far that level of security should be acceptable, right? And again, we don't have FHEs today. We're not going to have them for a very long time. So Ts is the best we have anyways. The question is that model acceptable from a security standpoint? And I think it very much is, unless your application is like securing government data and all of that. Yeah.
I think we might make audience a bit into confusion where we now switch to like safe compute and like FHE while we were back to ZKs. Maybe and if you want to like clarify the difference, because are they like a substituting tech, or is it like what benefits are we really bringing in with the ZK and somehow bring it away from?
So it's kind of a sliding scale of decentralization and proof and trust. So there's optimistic proofs, there's BFT consensus, there's zero knowledge proofs, which actually mathematically prove computations, and then there's trusted execution environments, which is essentially encrypted hardware that the owner and operator of the hardware really can't see what's happening inside the machine. And so, as my friend at the end of the couch was saying, like, it's great for privacy, where we can execute operations privately. However, a trusted execution environment is not actually proving to the client the output of the result. It's not proving mathematically that it executed a set of computations correctly. In the ZK space, we're mathematically proving that. In the TE space, we're just hiding work done by the computer from the owner of the computer, if that's a viable explanation.
Yeah, I agree. And like you can add some sort of receipt mechanism, which can itself be powered by ZK to just complete that entire, model. Yeah.
And so just last thing to quickly add, from an AI perspective, right, as the industry evolves and as decentralized AI becomes a term we start to hear every day, it becomes a little bit of a misnomer if it's not actually cryptographically proven or it's not actually decentralized. But there are teams that are starting to actually deploy LLMs in TEEs, starting to test actually doing some ZK proofs of machine learning models. And there are teams that are actually starting to like build decentralized networks that have other maybe optimistic or consensus-based proofs to actually decentralize that tech. And so the folks up here are bringing kind of different tools to the table. Is that fair?
Yeah, I completely agree. There's a kind of mix of different experimentations across different layers and modules that is happening in combination with all these technologies. In terms of like the more like LLMs and overall the AIs have become more of a consumer product, right? So we've seen a lot of like proliferation with this high big companies and stuff. What do you think like ZKs have to offer, or if there is like a ZK offer for like consumer centric apps or like this AI models for security purposes or like traceability or auditability, and where we might see it in a more like the Web3 world, or is that something like these big corporates could be take it, like integrate with their models and become a much wider standard that we could imagine?
I think someone, Brandon, was mentioning earlier today, like this idea that we might be in a world where we have agents that have information about us, and we don't want those agents to, necessarily disclose all that information, but they might want to selectively disclose parts of it in some situations in order to be able to interoperate with other agents, other systems. And so I think the moment that we start really delegating more of, kind of what happens in the real world about our identity to AIs, there is a case that those AIs should start using zero knowledge proofs when they're sort of negotiating with other AIs about what they're trying to get done on our behalf. I would add though, like, to me, like I by the time we get there, like, it's going to be a very different world. And another use case of AI, of ZK in particular, that isn't directly about AI, but is definitely relevant, is using like ZK for things like proof of identity, so that you can kind of prove that you are a real human in this world of many AI agents all existing. So it's not like, it's more of a mitigation, I would say, for AI, but I think one that seems also pretty essential in this world where you also have these AI agents doing all this much more advanced stuff. But, yeah.
Yeah, I want to add, like, so we have been also doing a lot of research on this internally, like what sort of, can you open up AI as a customer segment for our company, which is a ZK company? And so far we've just found one primary use case, and we are super excited about this one. So like, if you talk about AI today, it's trained mostly on the world's public data, what is available on the internet, like tweets and research papers, etc. But let's say you wanted an AI bot that was really good at, let's say, giving medical advice, you need to train it on medical data, and the medical data is extremely private today. So the world's AI has not been trained on the world's medical data, financial data, and all sorts of private data. And there's 7 times more private data out there than there's public data. So that's one of the areas we're excited about, that if we can use these combinations of TEs and ZK to enable confidential training of AI, can we actually enable AI models to be trained on your and mine and everyone's else private data without actually disclosing that data to any third party? So this is one area we are super excited about and are actually like working in some capacities.
So overall, yeah, medical data, and this is the kind of segment that you've highlighted. Everyone was more like generalized, like personal AIs. What other sectors do you think will be the pioneers and will adopt the zero knowledge proofs, or like this compute in a
Possibly an unpopular thing to say here, but I think it has a role in government, where the weights of certain models, you want to keep them private, maybe because they're trained, on personal data. However, whenever you're wanting to, make a kind of determination as to some output. So, for example, should somebody be granted a visa or some type of permit by a model in a government, you want to know that you're, as a citizen, being treated by the same model as everybody else. And if that model, the result of that model can provably demonstrate that it was, inferred from the same model that everyone else was inferred from, that's useful, because it means you have the scenario where the weights are kept private, so the kind of data compressed in those weights, which could be personal, is hidden from the public. However, you have faith and trust in that kind of centralized entity that they're actually using the exact same process that they're using for everybody else. So there's not any kind of unfair discrimination between different kind of subgroups in society. It's a little bit it's like a kind of solution to like issues surrounding extreme centralization, where you could force this citizenship, could like force the government to use zero knowledge proofs if they were ever using some kind of algorithmic system for making, policy decisions.
Yeah, it all sounded the perfect world, but governments, I got my own issues with the government, so I'm a kind of less believer. I want to do that to happen, but I'm the least believer of government trying to put their fingers and hands on in this technology because it's the
But if you trust
right.
if you trust the math, then you don't need to trust the government.
True, but then we don't need governments in a way. Okay, that's I'm out of this
I agree.
thing, but overall, that's the formula, right? Anything you want to add, Scott, in terms of the categories or industries?
Yeah,
you're
we're
excited
doing a lot of work with financial institutions and major American banks and financial institutions that are creating RWAs and tokenizing assets on chain. The challenge that they all have is all of their assets are in traditional cloud data warehouses that are kind of a golden record of their equities, their bonds, their everything they want to tokenize. And connecting that to smart contracts on their own L2s or on ETH mainnet is challenging, given that it's coming from a centralized source to the chain. And so we kind of act as like a ZK proven oracle in the middle to help these financial institutions onboard their assets in a cryptographically proven way, where we're proving from the data that we witness from the source in their source cloud data warehouse. I bring that up because that's another area it's blockchain tangential. It's enterprises onboarding to the chain using this technology. And then finally, there's some pedestrian use cases and there's some insurance use cases that are starting to come on chain that we're excited about for parametric insurance, where it requires cryptographic proofs of raw data from telemetry, from IoT devices, signed from the source, where we can run ZK proofs for the wind speeds in Florida. But where agents come in is where AI gets the AI angle here is interesting, because as more and more assets come on chain, specifically from financial institutions that want to tokenize things like allowing you to trade, Tesla stock on Ethereum, these agents will have capital and they'll be able to make those purchases themselves. And giving agents kind of policies and ZK proven rules that a smart contract can govern how the agent spends its money, what it can invest in, how it can withdraw, who it can send money to, is going to be very interesting.
I agree. On that note, maybe I'll ask a provocative question. So in the industry, there has been this narrative going on, especially recently, that overall, bringing this real world assets, all these like transactions on chain, that's a huge opportunity that was opened up, especially with the zero knowledge proofs and this kind of provable cryptography, right? But then there is this another aspect, which is this public ledgers of the blockchain. And now this narrative has been that if we want to really see the mainstream adoption and like financial institutions and the companies really onboarding to the chains, we need to crack the code and actually rebuild these public ledgers of the blockchains. How do you see the future of L1s, L2s, and all those industries basically making their bets?
I'm wondering if my friend from Mina shares the following opinion. My humble opinion is that ETH mainnet becomes kind of a settlement layer for ZK proofs, and more smart contract execution moves away from BFT consensus, where smart contract logic is redundantly executed 30, 50, 80 times across the validator set, and rather moved into ZK coprocessors or ZK provers that do most of the smart contract logic execution and state changes and prove the balances back up to mainnet. And so over time, I maybe see Ethereum just kind of becoming a bank that settles ZK provers. No? Thoughts?
I mean, I think so as well. Like, that's definitely how we think about Mina. We're not waiting for Ethereum in some way. We're trying to make that happen as soon as we can make it happen, because we think it's something we should exist. But yeah, we like, I think it's exactly, especially like from Mina, like we've gone to this very ZK approach. We're seeing the architecture make the most sense as the L1 being like basically the ZK settlement layer that serves to both settle other app chains, L2s, other systems, but then also provide bridging between all these different systems. So it becomes a place for settling like large accumulations of proofs, and then for communication between those different kind of stacks that can all talk to each other. And we're seeing that being something that can kind of be nested at that point, where the L1 does its own throughput, but each kind of stack does its own throughput, its own operations in its own ways. But they can still talk to each other through the layer one. So yeah, totally.
Yeah, I want to add on that. So I think the use cases for privacy, I've been super excited about that. I think the challenge so far has been that if you make something private, you also have to add KYC, at least to keep it compliant. I mean, I don't want to add KYC on it. I'm all for full anarchy, but I think that has been the challenge so far. I think Tornado Cash is a great example, which tried to sort of go the full extreme side, make offer complete privacy, anarchic privacy, as I like to call it. But I think they ran into some challenges, and I think we need to find that balance where the privacy is there, but it's some sort of auditable privacy where you can check that yes, something illegal is not happening. So I think that's the balance that we need to find when it comes to privacy side of ZK.
I just add that I think it'll probably bifurcate into kind of two separate parallel crypto economies, one of which kind of deals with institutions and maybe the kind of major L1s today, like Ethereum, are the settlement layer for that. But then I think there'll be a kind of side rail economy, which will become kind of more prominent as a result of that institutional adoption, which might exist somewhere like in the Bitcoin to Monero ecosystem, using atomic swaps or something like that to essentially provide non-institutional, kind of more citizen friendly crypto economics, because I think we almost saw like a version of this happen a couple of years ago for Tornado Cash sanctions, right? Where like people weren't processing blocks because of the U.S. government, etc. I think that was like a near miss, but definitely as more and more institutional kind of players adopt these large L1s, it will create like a greater demand for these sort of more private solutions for individuals.
Cool, I agree with the vision here. So overall, basically, I'll now go into more, how do you see the technology maturity in terms of like, we've seen like amazing stuff already working with the zero knowledge, right? And we've seen like applied it to multiple, even consumer facing stuff that I showcased a couple of minutes ago and stuff. But what do you think is this kind of backlogs? What are the technical things still needed from a security purpose, from like efficiency, performance purpose, and what is more or less these milestones that needs to be uncovered?
I'd probably say there's one hardware example where if we get to the point where we have FPGAs which can execute cryptographic circuits in a way that plays well with whatever the dominant model architecture is. So for example, right now one could say it's like transformer models, but whether or not that's a bet that you'd want to build a hardware company around for the next sort of 4 to 10 years is still, the jury's out. I think there could be something better than transformers that comes this decade. But once it's clear that there's something that's worthy of building, A, the circuits around, but then B, the kind of proving technology at the hardware level around, I think that would really scale up adoption, purely because it would make things so much more efficient. And efficiency right now is the core bottleneck, in my opinion.
What you want to add?
We're from a performance gain, or I guess from an improvement standpoint, we're focused on performance, and that's like been our North Star from the day we started Space and Time. I spent a decade running a database performance competitive team for a publicly traded company called Teradata, where like for a decade I was just like measuring basically query runtimes against every other database and trying to improve. So we're kind of taking that energy to ZK. Where we are right now is we're sub-second SQL ZK proofs against like million row tables on analytic queries, which is crazy. 3 years ago, I never thought sub-second would be possible. I was assuming like 5-minute proofs. And so now we're down to sub-second on million row tables, which means, sub 10 seconds on 20 million row tables because it scales sublinear. And the beauty of this is then now we can query information from the entire history of Ethereum, like the entire Ethereum state, or like look up 90 days of validator rewards near instantly, a couple seconds, return that query result and that ZK proof back on chain, next block. But I think things got to get faster and faster. And I think almost every ZK VM team, like every team working on generic ZK VMs is all is a race to the fastest proof times because people don't want to wait 10 minutes to get a proof back, especially if that proof slows down your transaction as a consumer on chain. If I'm borrowing from a lending protocol and that lending protocol asks a ZK prover off chain what my, how many loans I've paid off in order to give me a better borrow rate, I don't want to wait 10 minutes for that ZK proof to come back on chain and facilitate my loan. Rather, I want to wait one block. So we're just hyper-focused on performance, and we're expecting a lot of improvements in the GPU space and our own hardware improvements to try to make this faster and faster and faster.
think another one I would mention is like mobile proving, getting the systems fast enough, which I know actually you folks worked a lot on, but for general purpose zero knowledge proofs on mobile, on iOS, on Android, in a way that works well. So actually, I think you guys are probably at the cutting edge of that stuff, which is really cool. But that's one thing we're definitely seeing. I would say as well, like I do think it does seem plausible that the ZK systems will get fast enough to prove relatively large AI models at some point. At which point you can start doing some interesting stuff like having AI agents that are fully verified and interact with smart contracts on chain in some ways. But I think there's some of the performance stuff that it's going to happen, but we're not quite there yet.
Can I have a follow-up question?
Yeah.
You said you think that ZK will become performant enough that you can train AI inside that?
Not for training, just for inference. But inference for some of the larger models.
Interesting.
Where larger, I think, is, at the moment, probably like low single-digit billions of parameters seems possible for like applications. We were thinking where you're okay with like slow token, like asynchronous kind of output that still is kind of expensive, but not crazy expensive.
Interesting. Yeah.
You want to add on some of the exciting?
I just feel that, yes, obviously we need performance in ZK, and I think there are a lot of companies working on that. We also need use cases, which I think there are not many so far that as an industry we have found. I think we need to work on that. I think performance is getting there slowly, but the focus has to be on use cases at this point, in my opinion.
On that note, just close your eyes and like 10 years forward. What these people have on their phones or like applications and what is enabled. I know it's challenging and like crazy question to ask, but what do people have? Whether it's a user experience or like certain things enabled as an app or I don't know, something in their phones that should keep them excited, should keep them wanting to come year in year to attend such talks, and most notably to support us, to our early journeys and findings and stuff. Why?
10 years from now, absolutely no question, brain-computer interfaces and the models which are kind of, I guess, associated with your organic neurons, so the artificial neurons that will be embedded in the BCI will be making decisions on your behalf. And those decisions will need to be provably made in order for people to trust that it's something that it's you, quote unquote, without sharing the model weights. And a nice, I guess, feature of zero knowledge proofs is that they could solve that problem. So for super important decisions that your brain computer interface is going to make, you could put them through a ZK circuit.
A decade from now, in downtown San Francisco, a robot police officer will report the location coordinates of a crime to another robot police officer with a zero knowledge proof that it actually did the computation to find the exact coordinate and it's not lying to the other police officer.
I love that.
Yeah, I think like things. I suspect we will have something like AGI. At least personally, I don't even know if 10 years is a long time. But I do suspect if we're kind of make it to that world, it'll be a world where there are things like brain-computer interfaces, et cetera, and things will be much more integrated digitally. And in that environment, we're going to need good ways to like have digital trust between each other, between ourselves and institutions, the way we govern ourselves, and I do imagine zero knowledge proofs being kind of core to how we engage in that very different environment that has so much more computation that we need to rely on than today.
Yeah, I think I'm excited about two areas. The first one is some sort of privacy use cases around payments and DeFi and all of that, similar to what my friend mentioned around, like, let's say, privacy of institutional payments, etc. And second one I would say is like confidential AI training and something like that. Yeah, these are things I feel are quite realistic to see in the next couple of years.
Yeah, thanks for sharing all that. I definitely think a lot as well. And one of my ideas was like, okay, now if the camera can attest and like quickly do the compute on local side who you are, then what does the surveillance on the streets and overall this community looks like? And I think like not much will change. It's the fact that we'll be able to secure and make sure that there is no like this centralized aggregation and like human override to all these devices, whether it's like camera or like policemen or anything looking at how people walk, do daily stuff. But definitely this zero knowledge proofs is this language that will enable to not concentrate the power and all the bads that we see of governance in a single place, but even on the device level, make them smart and make them privacy preserving and respect the individual rules, but as well support the coordination and the kind of scale that the human society has, whether it's in your brain or whether it's a camera in the street. Okay, on this positive note, any secret stuff that you're working right now in the company and you just want to like reveal now?
We've been cooking up at Space and Time something very interesting for our mainnet coming up in April. About 2 years ago at ETHDenver, I think it was ETHDenver 2023. Our team got the idea of building just like a kind of like a Vercel V0 or like a Lovable, basically a creator studio for non-technical users to build smart contracts and front ends and deploy them to the chain of their choice, but particularly smart contracts that call space and time and get back ZK proven SQL data from Ethereum, from Bitcoin, from Solana, from ZK Sync, from Sui, you name it. And so what we're doing is we're making it really easy for anybody to just deploy their own smart contract that uses ZK. Just with a chatbot, like, hey, I want a little smart contract that you can fund some airdrop tokens and it executes a query with these criteria for the airdrop claiming. So when a wallet goes to claim their reward, it calls space and time and says, has this wallet completed these on-chain activities? If so, it releases the tokens for them. That kind of contract can be generated, audited, and deployed really quickly because it's simple and it uses space and time. So that's kind of what's coming soon for us in April.
I point people at our release yesterday, which is a verification system which doesn't use zero knowledge, but involves bitwise exact reproducible computation across different devices. An alternative to using zero knowledge proof systems is to do a more optimistic approach, but to make that efficient and to reduce the amount of redundancy that you might get in a BFT style system, you often want to have solutions where you can compare hashes in a very minimal way. And to do that, you need to solve the kind of non-determinism issues which are inherent to many machine learning models and workflows. We have a reproducibility framework and compiler which does that, and we premiered it yesterday. So Gensyn.ai/research.
Have any secrets you want to share?
I don't know about secrets, but I think like just two things to share we're currently working on. I think one is we're doing a lot of work right now on what we are calling application environments for zero knowledge proofs, which are kind of like on-chain places where you have an execution model for how zero knowledge proof transactions can interact with each other. So very deep in the stack, but something maybe is interesting. I think as well, maybe something to mention is we're going through security audit now, but about to release a standard for attestations on Mina. So being able to issue credentials, store those credentials in user wallets where they're secure and sandboxed, and then producing proofs about them for applications. So kind of like a general purpose way to issue credentials and make proofs about them that will be pretty widely accessible. So that could be interesting as well.
So we are working on this new product, we call it Photon. And the idea is that so there are many L1s like Fala Network, for example, who have built like a TE-L1. What we want to enable is, can we enable TEs to exist on top of any blockchain? And the challenge we believe that exists in that is that TE attestations are extremely expensive to verify on layer ones. By our estimate, it will cost you like $2,000 per TE attestation to be verified on Ethereum. Bitcoin even more expensive. Solana a little bit cheaper, but still quite expensive. And what we are trying to do now is using our aggregation layer, we will aggregate multiple TE attestations and create one single proof out of that, which can then be settled on the underlying layer one, which allows you to share the cost of TE attestations from multiple projects, reducing their cost quite significantly. Yeah, this is something we are launching very soon, actually.
Okay, thanks for sharing. We still got 4 minutes, so I need to ask one more question, basically, and let's go back to our primary focus, which was ZKs in AI or AIs in ZK, however you like. But overall, want to learn like what's your take on what is the maturity of the teams? Actually, they came in and really started off this ZK movement within the crypto, right? So there's a lot of teams I've interacted with. They're trying to solve, bring this crypto-focused AI interactions. What's your stance on that? So how do you value where mostly this team and the space is within the crypto AI form, and what could we expect from them that could be different from the mainstream, like the LLM models and stuff that we've seen?
I think the AI teams within crypto, they're more focused on the application side and marrying blockchain with crypto. So I think they're less likely to come up with some new thing over LLMs. I don't think so. That would be their mandate in general based on the sector they're operating in. I can say that as far as maturity of team goes, I think they are really good people. On the ZK side, I can especially say, because I interact with these folks a lot. I think on the AI side also we have some great folks, but there's generally a bit of challenge in attracting AI folks from the AI industry to crypto right now, I think. But I think as the use cases get discovered, that will change with time.
Kind of interpreting your question as, maybe differently of, are there any interesting teams that I like in the space? I quite like the ZKO open source project from Jason Martin. I think it's a good kind of, bedrock kind of flagship implementation of zero knowledge in the inference context. And it's been going a while now as well. It's been going for maybe just under 2 years, I think. So I think that's worth checking out, particularly if you're looking for, kind of plug and play proof systems.
I think agent teams have matured already. We've already seen almost the whole agent cycle in a matter of 4 months. Agent teams will continue to mature. I think the decentralized AI space was well funded, well capitalized in 2024, late 2023, I should say. And those teams are maturing, and one of them's right here with us, and I'm excited about that. But overall, I think there's room in this cycle for something else. I think we got room for one more play. I don't know what it is. Maybe it's agent.
Oh, I saw you would say it, and I was like, okay.
I don't know what it is, but maybe it's this. Maybe it's agents that deploy their own contracts or something. But I think your question was about the maturity of the AI teams in this space, and I actually share the opinion that I'm happy with the teams in this space. There's so many hot takes on Twitter about how dog shit AI and crypto is, and AI teams are not doing what Web 2 is. But I disagree. I think we've already seen very unique, very interesting examples where crypto capital and crypto community enabled an AI use case that really couldn't have been done in Web 2, i.e. virtuals, ELIZA, etc.
Yeah, I think it's a different part of the stack. I think we're on a pretty steep curve with a lot of the AI stuff in general, and the technology is proceeding so quickly that I think it'll be interesting to see what the teams make use of, kind of the latest things that are coming out very frequently. I think to me, it seems like we're just getting into a space where agents are starting to be more effective with some of the more reasoning things coming out. But even that is I could imagine in 3 to 6 months, those agents being maybe right now they're 30-40% of a person, maybe they'll be 80-90%, or they'll be parity even with a person, which would be very substantial. So to me, like I think that the teams are there. It's just like we're on this very steep curve of the agents themselves, and when will that be leveraged to do very different things? We'll see as the technology gets released, I think.
I share the excitement, all the beliefs forward. I want to thank you all for sharing your insights, and let's hope for the better and keep building, keep innovating, and keep merging different techs, bringing them in crypto and with the wonderful cryptography of zero knowledge proofs. Thank you all. Thanks.